I want to talk about some opportunities. Recessions can be very creative periods, second only to wars in the way that they force us to rethink the way we do things. Over the ages, great changes have often come out of adversity. The welfare state was born out of depression and global conflict, and a moment of crisis is precisely the time to think very boldly about how we can do things better in the future. I'm going to come back to some of the points that Bjorn makes in the second half of my talk. But first of all, I want to talk about some projects that demonstrate a new way of thinking that's particularly relevant to this session. In Bjorn's book, Cool It, he says that cutting carbon emissions inevitably costs money. In his words, there's no such thing as a free lunch. Well, I intend to demonstrate that it is possible to cut carbon emissions and save money. The key to it is innovation. I'm interested in biomimicry, and that's about using nature as a source of inspiration for new solutions. And I'll show you what I mean. Here's an example that shows the difference between the way that humans make things and the way that nature does things. This is aramid fiber, the strongest fiber that humans have ever made, almost as strong as spider silk. To make this, you take petroleum, you boil it in sulfuric acid at 750 degrees C, and then following the principle that if brute force doesn't work, you clearly haven't used enough, you pile on the pressure to get the molecules into place. So it uses extremes of energy, and it produces tons of toxic waste, and all that to do the same as a spider does at room temperature with raw materials of dead flies and water. So it does suggest there's some room for improvement. And when you think about it, perhaps it's not that surprising. After all, nature has had quite a long R&D period, 3.5 billion years, in fact. And all the faulty products have been withdrawn from the marketplace. And this was something we came to realize when we were working on the Eden project. And we turned to nature at every stage, looking at bubbles at the strategic stage, and we even used dragonfly wings to help us resolve the steel junctions. Now, it was a tough site because it was still being quarried, so we had to come up with a solution that would work regardless of what the final ground levels were going to be. And the concept we came up with was to conceive of the building as being like a string of bubbles, and the diameters of those could be varied to provide the right growing height in the different parts of the building. And then the necklace line that joined those together, that could be varied to suit the approximate topography. We did lots of iterations of this, setting this into a terrain model, and by cutting away everything that was below the ground, we generated the first image that looked something like the completed building. We knew from lots of natural examples that the most efficient way of creating a spherical surface is using geodesics, hexagons and pentagons. The next challenge was to enclose it in the lightest way possible, and we had to find an alternative to glass, which is really very heavy and very limited in terms of its unit size. So we settled on ETFE, a high-strength polymer, ethyl tetrafluoroethylene, or cling film with attitude, as Tim Schmidt called it. And the way you use this is you make it in 3 layers. You weld it around the edge and you inflate it for rigidity. And the great advantage of this was that you could make it in really huge sizes. And we found that we got into a positive cycle in which one breakthrough facilitated another. So with really large units, it meant that we had less steel. With less steel, we were getting more sunlight in, and that meant we didn't have to put as much extra heat in winter. It also meant that we had far less substructure. And the end result was a superstructure that was lighter than the air that it contains. It was also 1/3 of the cost of a conventional glass solution. And the ETFE pillows were 1% of the weight of double glazing, a factor 100 saving, achieving the same result but with 100th of the resource input. So the Eden project is an example of what can be achieved by looking at natural forms for inspiration. Radically lower carbon at lower cost. The next project is inspired by natural systems. And it was another tough site because it was a landfill facility. And the brief was for a project similar to Eden, but this time in the north of England. The client also wanted it to be zero carbon. Now, landfill is such a crazy idea that we decided we were going to respond to this in some way. And there was a nice scheme that we were aware of at the time called the Cardboard to Caviar project, done by the Kirklees and Corderdale Green Business Network. And in their area, they had quite a lot of posh restaurants. And generally speaking, they were working like this. Highly packaged foodstuff in at one end, a lot of landfill waste at the other. Now, the really clever bit is what they did with the cardboard waste. Because they were paid to collect that, they shredded it and sold it to equestrian centres horse bedding. When that was soiled, they were paid again to collect it. They put it into worm recomposting systems, which produced worms, which they fed to Siberian sturgeon, which produced caviar, which they sold back to the restaurants. So it's transformed a linear, wasteful system into a closed-loop system, and that's exactly the way that natural systems work. It's also like a form of alchemy, turning a very low-value material into a high-value material and earning money on the way, ending up with caviar, and I'd call that a pretty good free lunch. So this inspired us to use the biodegradable portion of landfill and put that into biodigesters set into the walls of this building. So for a lot of the year, the building would be self-heating, just based on solar gain and thermal mass, but then during the colder times of the year, we could draw heat off that compost to heat the building. And we did quite a bit of further work on this, looking at some of the economic benefits. And we found that the value of the energy, the compost, and the landfill tax added up to £9.5 million a year before we had a single visitor through the door, transforming a big problem, landfill, into a massive opportunity. So the eco-rainforest shows what can be achieved by creating man-made systems that mimic the remarkable efficiencies of natural systems. And here's another example. This is a brewery that transformed its waste into a whole web of activities. So rather than just producing beer, it was now producing bread, mushrooms, pigs, gas, fertilizer, free lunches all over the place. We could do the same with our towns and cities, looking at the whole metabolism of cities and treating all waste as an opportunity, creating systems with radically lower carbon emissions and yielding much greater value. So we've looked at natural forms and natural systems. Now we're going to look at a project inspired by natural processes. And the real hero for this project is the Namibian fog-basking beetle. And this beetle has evolved a way of harvesting its own fresh water in a desert location. And the way it does this is that it comes out of its hiding place at night. It radiates heat out to the night sky, so it becomes just slightly cooler than its surroundings. And when the moist breeze blows in off the sea, you get these droplets of water forming on the beetle's shell. Just before morning, it tips its shell up, the water runs down to its mouth, it has a good drink, and then goes off and hides for the rest of the day. I think it's fair to say it's not a great quality of life, but it is a clever trick. And I'm working on this project with an engineer called Bill Watts and a chap called Charlie Payton, who invented the seawater greenhouse. It's an absolutely brilliant bit of sustainable design. It's designed for coastal arid regions. And the way that it works is that it evaporates seawater from grills on the windward side and condenses that moisture as fresh water on the leeward side in a process almost identical to the beetle, just using the sun, the wind, and a tiny amount of pumping energy. The remarkable thing about this scheme was that it was actually producing more fresh water than it needed for the plants inside. It was nowhere near a town, so they just decided to spread this surplus water on the land around. This photo was taken just after completion, and 2 years later, it looked like this. So it was like a green ink blot spreading out from the building, turning barren land back into biologically productive land. And in that sense, I would argue that it's actually going beyond sustainable design to achieve restorative design.